Hi everyone, welcome back to Curtitus Math. So today we're going to do a little review on solving for an unknown. So this is when you have an equation with an x or any other variable in there and you want to solve for that variable. So we're going to start off with this first example, x plus 3. So when you're solving for x, you're trying to figure out, well, if you have something plus 3 and that gives you 8, well, what does that something have to be? And the process for doing this is that whatever is happening to this x, so here you have plus 3, you need to do the opposite operation in order to figure out what x is on its own. So what we do here is we subtract 3 on this side, and since you want to keep that equals, you don't want to disturb the equality, then what you do to one side, you need to do the same thing to the other side. So by also subtracting 3 on this side, we're keeping everything balanced and we're not disturbing that equality. And then you just do that operation. So here you have 3 minus 3, that gives you 0. That's what we wanted. We wanted to get rid of that 3. We got x. And then on this side, we have 8 minus 3, and that gives us 5. So our value of x is 5. Okay, so that was a bit of a simple example. So number 2 here is a little bit more complicated. You have 3/4 of x gives you 6. Now there's a few ways that you can do something like this. You can change it to a decimal if you'd like to. So if you wanted to rewrite this as 0.75x equals 6, and then notice, well, if I change it to a decimal, then this operation between my 0.75 and my x, that's a multiplication. So in order to undo my multiplication, I need to divide. So if I divide here by 0.75, then that means I also need to divide here by 0.75. So you can do it that way. And then that will give you 6 divided by 0.75. That gives you x equals 8. That's one way to do it. Another way to do this is to actually just divide by the entire fraction. So you would write, so you see that 3/4 is multiplying x. So if I divide this whole side by 3/4 and I divide 6 by 3/4, I'll also get x by itself. So here, these will cancel out. I get x by itself, and I get, on this side, 6 divided by 3/4. You could punch that directly into your calculator. You could also do it manually. And when you multiply fractions, you know that they have to flip. Divide fractions, they have to flip. So this division would change to a multiplication, and then my fraction would flip over. So I'd have 6 times 4 over 3. And that 6 is over 1. So over here, I would get 6 times 4, 24 over 3. And then you can do that simplification, 24 divided by 3. That would give you the same thing of x equals 8. So that's if you kind of wanted to jump into the whole dividing by the entire fraction. And then I'll show you the way that I actually prefer to do it, which is kind of step by step. So I'm going to erase this. We're going to arrive at the same answer. So the way that I do this is I see this as, this is 3 times x and then divided by 4. So it doesn't actually matter which order you do, you get rid of the 3 or the 4, because if we remember order of operations, bad math, we know that we have to do brackets first, exponents, then division, multiplication, and then addition, subtraction. So division, multiplication are kind of at the same level. It doesn't actually matter which one you do first or second. in this case here. So what I'm going to do is the first thing I want to do is get rid of that denominator. It's kind of ugly. So since here I'm dividing by 4, I'm going to multiply by 4 to get rid of it. So that means I'm doing times 4 on this side and I'm doing times 4 on this side to get rid of that division of 4. So what's left on this side is 3x, since I have now canceled out that division of 4. And on this side, what's left is 6 times 4, which gives us 24. Now what I have left here is 3 times x equals 24. To undo my times 3, I have to divide by 3. And what I do to one side, I have to do to the other to keep that equality going. Get 24 divided by 3, x equals 8. So this ends up being the same process as, dividing by the entire fraction, but you end up doing it in steps instead of doing it all at once. And I think it's just a little bit neater to look at. So either dealing with the fraction kind of numerator denominator one at a time, or changing it to a decimal if the fraction you have actually changes into a nice decimal. If you had something like 1 over 3 or 2 over 3, this would be kind of ugly to deal with, so I would suggest sticking with the fraction version. Okay, so moving on to number 3 over here, we have 5x plus 7 equals 22. So again, remembering that BEDMAS, when you're solving for unknowns, you're really doing BEDMAS in the opposite direction. So instead of starting with brackets, then exponents, then division multiplication, then addition subtraction, what you do is you do BEDMAS the opposite way. Because instead of starting with this x number, if I had this x number, if this x number was, say, 1, well, the first thing I would do is 5 times 1. And then the second thing I would do is add my 5 and 7 together. But now I'm going backwards, right? So I want to get back to 1 from this. So the first thing I have to do is not divide by 5, it's subtract this 7. So I want to subtract the 7 so I can get back to this. And then I would divide by 5 to get back to this. So you're really doing your BEDMAS in an opposite direction. And that's one way to kind of think about it. So here, I know that between the two operations that I have a multiplication here and an addition here. Addition is the first thing I'm going to be undoing. So I want to get rid of that plus 7, which means I will be subtracting 7. And what I do to one side, I do to the other. So here I get left with a 5x equals, and now 22 minus 7, that will give us 15. Now I have 5 times x equals 15. And the opposite operation to multiplication is division. Excuse me. So now we are going to be dividing by 5 to undo that multiplication. And we get x equals 3. And that is the answer for this example. Okay, moving on to number 4. So this one, again, we have to think about that BEDMAS is a little bit more interesting. Since, so something like this is, you have to look at it a little bit differently, because as I just said, is that when you have, so again, brackets, exponents, division, multiplication, addition. So we have, again, two operations here. We have an addition and we have a division. So in the previous example, we said that we always start by undoing addition, subtraction. But there is a catch in this case. We are actually going to start by undoing this division because this giant fraction line here acts as a bracket. So if we were to be doing this problem, right, So we always kind of want to start by the last step that we would do in a real problem. So here, if I knew what x was in this case, and again, let's use the example that x is 1. If I knew what x was, well, the first thing I would do here is not divide or multiply. The first thing I would do is do this addition because this fraction line acts kind of like a bracket. This is kind of the same thing as 1 plus 4 and then divided by 2. So because this acts as a bracket, the first thing we end up doing, if we had this value of x and we're pretending that value is 1, the first thing I would do is add them together. And then the last thing I would do is divide by 2. So now when I'm undoing this, when I'm solving for that unknown, I want to start with the last step of if I had that number. So I have to start by undoing that division of 2. So here the step is that we are multiplying by 2. So you can show this like this, or you can just write it times 2, whatever makes the most sense to you. So I really like the brackets because I like doing this cross, cross. It's so satisfying. X plus 4 equals 10 times 2, we get 20 over here. And now we can finally undo that addition. So the opposite of plus 4 would be minus 4, and what we do to one side, we do to the other. So we get x equals 16.